Hello.
Hello, welcome to another stream. How about that? Bet you didn't expect that shit to happen yet again. Hello, Hearts and Plots, Mr. Botka, Miguel Zodias, Watery One. I hope I pronounced your name correctly. Thank you, by the way, for subscription. Thank you. Sasa Lala 23, Apparently Potatoes, A Good Duke, Desu Used, Winter Coding. Hello, welcome. So, today is Tuesday, if I'm not mistaken, and that means today, according to the schedule, we're continuing developing our virtual machine. That's right, that's what we're doing. That's what we're doing. We did that yesterday, we're gonna be doing that today, and we're probably gonna be doing that tomorrow, so we do that for 3 days. 3 days of a virtual machine. You can find the source code there, and let's just jump into it. Let's just go ahead and do that. So maybe before I start, it would make sense for me to pour a cup of tea. How about that? I prepared some tea right before the stream, off screen. Yeah, you didn't see that. So yesu akawai desu. All right. So what did we do yesterday? I think yesterday we were working on printer, the floating point printer. We finally fixed the bug with floating point printing, and on top of that we developed like a simple region-based memory allocator that I plan to integrate into our virtual machine today. But before I'm gonna do any sort of integration with memory management and stuff like that, I think I want to review some of the pull requests that were submitted by Nico to the project. Alright, so we have a couple of pull requests that I wanted to go through. So all of them are related to virtual machine debugging. And let's see how it's gonna go. So the first one is implement stepping over call instructions. Okay, so this is something that I've been struggling for quite some time. Yeah, and finally we have that functionality. Thank you so much, Heroes and Plots, for implementing that. First time using community challenge. What are you guys talking about? Stream promoted. I don't know how it works. It doesn't really affect my statistics too much, but maybe it does. I don't know. Like, I didn't notice a significant boost. I once saw a keynote which presented a minimalistic virtual machine that had no users, nothing, and where you included its part for networking, file access, and so on in a static binary with a whole VM or in your program. Is this similar? We don't really have, you know, file access networking yet, but we do have basically printing on the standard output. But we have a room for extending the virtual machine and actually adding these kind of things in the future. So right now I'm not really focused on interacting with the external world too much, because the internal world is not really finished yet. How do you include no build into BM? Just copy it? I personally do just copy it. Yeah, I guess. Hello Cerimon, welcome to the stream. Hello. Okay. So yeah, so this is what this issue is all about, right? So let me what's the branch I'm in? Let me take a look to the master. Let me go to the master and merge origin. Origin master. Is it already merged? Did I not merge that program, that branch? 154. Huh. What is 154 issue is all about, and why do I have a branch about it? I don't quite remember. 154. Oh yeah, so it's a branch for memory allocation. I see. So everything's okay. I can actually leave this branch here. So I'm gonna check out to master. I already checked it out. So what remotes do I have? Do I have a Heroes and Plots remote? I think I do. So I'm gonna just fetch the Heroes and Plots remote, and we're gonna start. So essentially, let's try to reproduce the problem, right? Let's try to reproduce the problem. Imagine that we have a program like a Fibonacci thingy, and one of the things the program that computes Fibonacci numbers does is it calls a function dump u64, which is a function from the standard library of BASM, and it basically takes your number and prints it on the screen. So it parses the digits, and then it, you know, prints everything on the screen. So if you try to debug the program right now, before we can try to run it, let's actually rebuild everything just in case. Alright, so then we can do something like this. BDB, and in examples, I'm gonna go to the Fibonacci, right, and I'm gonna break on main, and I'm gonna run the entire thing, right? I'm gonna run the entire thing. So if I start stepping through the entire thing, well, I would expect that when I step one more time, I will actually step over the call. Right, I will step over the call, but that's not what's happening. You actually start stepping into the function itself, and the function dump u64 is actually quite involved, because it parses literally the number and converts each digits to as ASCII symbol, and then puts them all on, to the memory, and then calls the right syscall to put that on the screen. So it's quite involved, and you usually when you're debugging your logic, you don't want to look into that. So it would be way easier if you could step over these kind of calls. So yeah, and that's exactly what this pull request is about, right? It allows you to do that. And I suppose it also separates different commands for just stepping over and stepping into the function if you want to do that, right? As far as I know, in GDB, N steps over and S steps into, if I remember correctly. I think that's how it goes. So I don't know what kind of conventions we're going to follow in this particular situation. So yeah, let's take a look. So 57 changes. This change the names of the following command. Stack dump can be printed with P because S is already taken. Single stepping instruction can be done with S, and stepping over instruction can be achieved with N. Okay, so that's pretty good conventions because we got used to them. You get used to them if you use GDB. All right, so we have a special stepping over mode. Okay, so let's actually see how it works. So let me take a look at the stuff in here. So step over call. Yes, I suppose that's the thing. Check out -b, and I'm gonna do step over call. All right, and let's rebuild everything just in case. And let's start the debugger. I'm gonna break on main and let's run it. And next. So let me actually open the program that I'm actually debugging right now, so I can see what's the next instruction after the call, after the function call, so I can confirm that we actually stepped over it. So bm examples fib basm. So after the call we have dup1 plus I and so on and so forth. Might as well actually bring this kind of stuff here. Yeah, so here we have a call dupu64, and now we have dup1, and it also actually printed the number, so it actually executed it a little bit and then stopped after the call. Plus I, swap1, yeah, and so the stack is actually printed like this. Alright, so it seems to be working, and I'm super happy with it. Thank you so much for implementing that. Alright. Looks good to me. Thank you for the contribution. There we go. Thank you for the contribution, and let's merge the pull request. Epic. Absolutely epic. I really want to go through all the pull requests before I start integrating the memory management stuff, because it may require changing a lot of things in all of the tool set. So I don't want to create any particular merge conflicts. Okay. Introduce W command in favor of I command. I don't remember what was I. Deprecates I command, as you can use W command instead of printing information about the current location. Oh, I is the IP, right. So it already conflicts. Okay, so you basically... please let me know if you have any issues with the changes. Okay, so... well, I have merge conflicts, so let's take a look at them. Print location, so there will be no I, and where prints the location, and what's the location actually? Let me take a look at the print location. So it takes the IP, it iterates over all of the labels, right? It iterates all of the labels, at address, and I see. Oh yeah, it actually searches for the label. Yeah, it searches for the label. I see now. I see. Okay, that's pretty cool. Essentially, right now, right, if you debugging some stuff, right, and if you try to look at the IP, which is instruction pointer, by the way. IP stands not for the internet protocol, but for an instruction pointer. It doesn't really tell you that much of the information, right? It's not really useful number. It's just a number of an instruction, and how can you... it's not even the line of code, because the number of the instruction does not correspond to the lines of code. So it's kind of useless. So I suppose Nico introduced a command that prints you under which label you're currently R, right? So which is pretty useful, I think. So let's take a look at that. Check out to master. So what are branches? Print label call. I think it's BDB where. I think that's what we're doing right now. Git checkout -b BDB where. All right, unless you build everything. Okay, so what's the warning? Comparison of unsigned expression 0 is always true. Compilers are kind of funny. Why is it always true? Oh yeah, because it's, yeah. I see. Yeah, it's actually kind of dangerous because if it goes lower, right, if it goes lower, it will overflow and it's gonna be a huge number. So this needs to be fixed actually. I can fix it, so it's not that big of a deal. Should I be here if I'm new with coding and Python? Well, who am I to tell you what to do? Like, you can do whatever you want. You can be here. You cannot be here regardless of anything, regardless of your background. So don't let anyone to tell you what to do, right? Especially on the internet, by the way, especially in the internet. Because the internet is full of weird people who think they know better than you, but it's not true actually. So yeah, you want to stay here? Stay here. You don't want to stay here? Just close the tab and move on. Who am I to tell you what to do? You should be here and subscribe. Well, that's an option too. Why not? That's an option too. Alrighty, so let's actually find this thing here. bdb.c. 289. Alright, so how are we gonna actually process all of that? So if you reached 0, right, if you reached 0, all right, so maybe we can start with, so this is IP and you need IP here. Okay, maybe we can start with reorganizing this loop slightly. Okay. While data labels data. Oh, so you have, that's a very interesting state. Wait a second, let me take a look at this. So basically for each line of code, oh, huh, so for each line, for each rather instruction, I see, for each instruction you have a correspondence of a label. All right, so that means you have while this thing is equal to null, right? While it is equal to null. While it is equal to null, what we're doing here, we're doing just a lock, right? We're just doing lock, and we're just going up. And another interesting thing, while you know, lock is greater than 0 and this thing is greater than 0. Okay. So after that, you can literally move this entire thing here. Alright, you can literally move this entire thing here. And if you do have data here, you print that. Otherwise, you print that, right? And then you can just return this entire thing. You may even do it like that. I think I understood the logic of your loop correctly. Did I understand it correctly? I think I did. Right, so essentially, right. Yeah, we go back as far as we can until we hit the label or we hit the 0, and then we check that again in case we hit the 0 and there is nothing there. Yeah, I think it's a little bit more safe now, right? It's definitely more safe. It cannot overflow or anything because instruction address is unsigned. Yeah, it's pretty cool. Okay. So yeah, well, we're gonna fix the formatting thing a little bit later. I was thinking what to use for formatting. So obvious choice would be something like Clang Formatter. But Clang Formatter, like, I had problems with Clang Formatter on my machine and CI. For example, I had situations. Hello Kane423, I didn't notice your message. Please speak English. Unfortunately, majority of people here, they don't speak Russian. Yeah, I can understand you, but like most of the people cannot, so I'm really sorry. So what I wanted to say. Clang format, right? Clang format. Yeah, I had problems because of different versions on my machine and on CI. Right, and configuration, the same configuration act differently on my machine and the CI. So, and I couldn't find any solution to do like for that. Except actually upgrading my Clang format, and to upgrade my Clang format I had to upgrade my whole fucking Clang toolchain or something. So it was really fucking strange, like, yeah. So, and that's why I don't really want to use Clang format, I'm sorry. I found a very interesting tool called A-Style. Have you guys heard about it? It's like a very old one. It's like an old formatter for C and C++, and it's actually for several like C-like languages. And it supports KNR style, and I was thinking about like using it. So I think I even installed it. If it's even available on Debian, that means that it's probably going to be available everywhere. Yeah. A-Style. Main A-Style. Multi-language digitation and formatting filters. So, has anyone heard about A-Style? I don't know. Seems pretty cool. I don't know. I wanted to give it a try. I already tried Clang format and I didn't really have a pleasant experience with it because I had to support multiple environments. But I haven't tried A-Style yet. Maybe I'm gonna have a good experience with that one. What's the default C-like language format? I think KNR. I think KNR is considered the default one. KNR C-style formatting. Indentation style. Yeah, KNR style. So by Kerrigan and Ritchie. So the one true brace style in hacker jargon, I don't know. Like I personally just developed a habit to use this specific style. I don't really have any, you know, arguments for or against this formatting. The only reason why I use it is because I got used to it. So yeah, if I spend time learning different style, I can get used to that style as well. So, and I was thinking, since I got used to KNR and A-Style actually supports KNR, you can put like a flag dash style KNR and it will apply KNR to all of the entire source code. Yeah, A-style is apparently like a very old thing. I think it existed before Clang format or something like that. It's just, yeah, it's pretty interesting. KNR Original C, yeah. Original C. So I think, I'm kind of thinking applying this style for my project. So yeah, there's also Linux kernel. Wait a second. So there was documentation on the usage. KNR. Yeah, there we go. This is how you apply the styles. So you can put KR or KNR. You can put Java style, Stroustrup style, some other styles I never heard of. Does it have a Linux style? It might have a Linux style. Oh yeah, it does have a Linux style. Would you look at that? No, it has a lot of different styles. That's actually pretty cool. To know that. And what's funny is that like you don't even have to configure that, right? So you just pick a style, really well-known style like Google style, and it will just use it. That's a pretty cool tool. Like at least on paper, right? In reality, I don't know how useful it is. But yeah, on paper so far it's very interesting tool. Anyways, so yeah, what I was doing, I was looking through the where. Yeah, I was actually fixing the loop. I was fixing the loop. All right. All right. I use WordPress style, absolutely fucking horrible. Does WordPress have its own specific style for PHP? I didn't know that. I'm not a really PHP developer, so I know nothing about like conventions in PHP world. I'm really sorry about that. Even though I sometimes like make fun of PHP, but I mean it's just a meme. Just a meme. All right, so let's try to do BDB. What? You don't actually program in PHP? Unsub. Unfucking sub. I swear to God. Oh, fuck. Alright, so let's break on main. Let's run this entire thing and where? Add address to 70. Oh, this is actually pretty cool. It also shows you the offset. That's pretty useful, I think. Yeah, and then where +2. That's actually pretty fucking goddamn cool. And then I want to step into that. Oh fuck. Oh shit. Oh, I even know what kind of conflict you have here. I know exactly the conflict. So oh shit, destroy computers.
You need again at the turn of the tide.
Indeed. Thank you so much for 21 months of tier 1 subscription. Thank you, and welcome to our epic virtual machine club. How about that? We're developing a debugger. Well, I mean, I'm looking through the pull requests and stuff like that. So this seems to be okay. All right. Try to make the location search loop fix unsigned overflow in the location search loop. Right, I think that's what we're gonna have here, and I'm gonna push that right into your repo. I'm sure what I use, probably some random variant of KNR. Probably. I personally don't care about specific style. So what's important is that the style is uniform across the whole project. Yeah, it's a virtual machine. We're doing virtual machine. And yeah, to enforce that, I think we need to run some sort of a formatter on CI. And every time somebody tries to put something that is not properly formatted, the CI should break and force the people to fix everything. Oh, by the way, recently, have you guys heard about it? Recently, GitHub introduced like auto merging for projects, for pull requests, which is actually kind of interesting. GitHub auto merging. Or yeah. So essentially, if your CI strong enough, and you do believe into all of the CI checks, you can enable this auto merging. So essentially, pull requests will be automatically merged as soon as CI is green. right? If your pull request doesn't break anything, it's automatically merged. But I think to enable something like that, you have to put a lot of effort into your CI. You have to put shit ton of different checks and stuff like that. But if they're good, I think you can try to enable something like that. I think it's pretty interesting. And basically go completely reviewless, right? So, I don't know. It's pretty interesting. But I never tried it myself. Yeah. Prerequisites for writing a VM, compiler knowledge and stuff like that. I know nothing about compilers and I'm writing a virtual machine. I think the prerequisite of writing virtual machine is a desire to write a virtual machine. Just if you want to write a virtual machine, just fucking write a virtual machine. It's not that hard, actually. Just go ahead and write. So, because what is a virtual machine? Right. So, what defines a virtual machine? I don't know. For example, is a calculator a virtual machine? Do we have something like a GUI calculator, like Windows GUI calculator? This one. Is this thing a virtual machine? Well, it emulates like a real hardware thing, right? So it's a virtual machine. So yeah. So virtual machine is not necessarily something super complex. There could be very simple virtual machines and there could be super complex virtual machines, right? So it's just you take a machine, right, some sort of a hardware, and you emulate it and you basically describe that hardware using code. That's it. So this, in my opinion, this also could be called a virtual machine. Why not? Sure, you're emulating like a real calculator, which is like a real hardware thingy. So yeah, you can come up with your own non-existing hardware and call it a virtual machine. Why not? So yeah. Anyways. Yeah. Oh shit. Cool. So we probably need to resolve the merge conflict. So to resolve the merge conflict, I want to merge everything with the master and let it fail. It didn't fail, actually. Ah, I know why. I know why. Because we haven't fetched the latest changes. So let me quickly fetch everything. So technically apps inside f is equal VM in a VM. Depends on the definition. My point was about like what's the virtual machine? Well, it depends on the definition. You can define a virtual machine however you want and then implement whatever you want, right? Because there's no strict definition of a virtual machine, right? That was my point. What you're asking is actually kind of against my point, right? You're trying to give the like rigid definition, but that's not my point. My point was a virtual machine doesn't have a rigid definition. You can call whatever the fuck you want a virtual machine and then implement whatever the fuck you want. Right, so if it's a virtual, it's a machine, you might as well call it a virtual machine. So... I don't like the association you made of a VM with emulator. VM is not an emulator. Thank you for sharing your opinion. Yes, I'm really glad that you shared it. If you don't like something, speak up. Yes, I like your attitude. Thank you so much for telling me. All right. Let me see. For example, I personally don't like when it's minus 40 outside, and I constantly talk about it. So yeah, as you can see, I also share my opinion about things I don't like. Okay, thank you. Let's share opinions. Yes, let's share opinions together. It's so great. All right. So what do we have here? So I have the latest shit. So can I now merge? Yeah, so now I can merge that. Merge with the master, and hopefully that will, yeah, so basically it starts to conflict, and it conflicts exactly here. Whew, all right, so let's actually start with something simple, like help. Let's take a look at the help. Excuse me. Yeah, there we go. So we have a so this is a step instruction. We don't have s as a stack dump, right? We don't have s as a stack dump. We do have a print location info. We do have a print location info, and I don't remember if we do have an instruction pointer. Do we have an instruction pointer? I think we don't have it anymore. So I was straight up deprecated. Okay, so it was actually straight up removed, and it was replaced with that. Cool. All right, so I think I didn't miss anything. Step over instructions, step instruction, step over instruction, continue, print location, and overall everything looks okay. Everything looks okay. Okay, let's take a look at some other stuff. So, and you know what? Maybe I have to put it like that. Step, yeah, so that looks a little bit better. Print. So maybe if I swap these things around, yeah, I think that's okay. All right, so we have N, W. So this one is kind of interesting. So we don't have I at all. So that means the easiest thing for me to do is just to remove everything here, I suppose. Right, step over instruction, that's something very important for us. Then remove that and remove that. Okay. Emacs, are you okay? All right, so we just, yeah, we added a step over instruction. And I think we actually resolved all the conflicts. Before I continue merging, I need to build everything and confirm that everything's okay. I need to confirm that everything is okay. And is the music even playing? I can barely hear the music. All right, so let me see. So maybe I also want to run the tests. We didn't do any modifications to the original thing, but yeah. Okay, continue, commit merge. All right, so, and I'm gonna push that right into your repo. So, and this is how we resolved the conflict, hopefully. Did it actually push anything? Okay, it pushed everything. Break main, run, so make a couple of steps, then where, and oh yeah, so it actually, did it? Oh yeah, so it actually went to the loop, and that's okay actually. Cool. So let's continue. So we only need to wait for continuous integration. All right, so what's gonna be the next thing that we're gonna work on? Oh yeah, we need to work on the memory management thingy. So yeah, I'm gonna merge it right now. Looks good to me. Thank you for your contribution. All right, I'm gonna merge that. Alrighty. So yes, we're ready to actually start doing things. So what I want to do, I want to integrate Arena allocator that we developed yesterday. So you can find the example here, right? You can find the example here. And what we're gonna do, we're gonna basically just integrate it. Nothing particularly special. Just integrate it. Just integrate it. Because right now our allocator looks like. Let me see, it's located in BM, right? So it's gonna be Arena. Yeah, it's basically like a static memory, like not static memory, but fixed memory with a particular capacity, and capacity is just like, you know, fixed capacity. Nothing particularly special, right? But for the systems where you cannot have this much static memory, or this much especially static memory, it could be a problem to run the programs and stuff like that. So yeah, that's basically what we're doing. Okay, did I merge everything? Okay, so let's go ahead and fetch the latest stuff. Origin master, and there we go. And I think the issue that we're working on right now, we'll have to 54 error allocating static memory. Okay, so yeah, we're working on that with, in the scope of that specific issue. So this branch is actually a little bit behind, so I have to fast forward it super quick. Yes, I just fast forwarded it to the master, where we did all the important work, and we can start, you know, integrating everything. So I also have this thing that is not important, some garbage and whatnot, and let's rebuild and test everything. So let me grab my Arena allocator. So what I'm thinking is that I'm gonna just straight up copy paste this. I think I'm gonna straight up copy paste it and see how it goes. vm.h, where is my Arena? Where is my Arena? Where is it located? Arena and its capacity. I don't think we need to have any capacity at all right now, and yeah, this is gonna be the Arena. Okay. So here's the region and the Arena itself. Yeah, we also need to be able to create a region of a particular capacity, so that's quite important. So this is going to be the function, and Arena itself is going to be defined. Oh shit! Arena itself is going to be defined as something like this. Without stream DMCA bullshit, what's the go-to music genre you listen to? I don't listen to music while I'm coding. Alright. So we have Arena alloc, which has the same... yeah, it basically has the same signature. So, and we will need to add this thing in here. Have you thought about using mmap for the region? You get zeroed memory for free. Yes, I thought about it, but it's not cross-platform. There are operating systems where there is no literally there is no such thing as mmap. And one of such operating system is one of the most popular operating system on planet Earth. Hello, John. Welcome to the stream. Welcome. Alright, so do I need a summary? I might as well actually have this function here as well, because why not? Alright, so yeah, we just need to integrate this alloc and whatnot. Okay, so where do we have a yeah, so now we need to get this entire thing and just copy paste this implementation here. Zozin, why are you copy-pasting code? Why don't you implement it yourself? Yes, I'm stealing someone else's code, by the way. That's literally what I'm doing right now. Alright, so region create. So let's actually bring region create here as well. So for those who don't know, we implemented this thing yesterday, so you might as well actually go watch yesterday's stream. And yeah. So here's the location, so then we're gonna have a clean, free, and summary somewhere here. And yeah. Windows has virtual lock. Okay, so that means on different operating systems, like I will have to use different calls, and I'll have to write some sort of like a layer on top of virtual alloc and mmap to basically, you know, do the same thing on different operating systems. Oh wait, I already have that layer. It's called libc. Oops. Anyway, so let's continue. Clean, free, summary. Okay, looks cool. Alright, so here, expected int, but this one is size t. Okay, so this has to be ZU then. And in here, when I clean, why clean have to return anything? Yeah, I don't think it has to return anything. Okay, so arena size has no member. Oh yeah, okay. So because of that, we cannot have this function anymore. So this is not a function that we can have. So and then, yeah, majority of the problems are actually coming from BMR. Yeah, so we'll have to rewrite BMR now. Okay. So actual arena, it's the arena. So shit, I'll have to remove the actual arena here as well. So BMR, right. This one is very interesting. How are we gonna approach this entire thing? It feels like specifically for BMR, I'll need to implement the stretch buffer into which I can write things, and the arena is not gonna actually cut it for me. So I guess, yeah, we need to implement that. Because and unlike in case of arena, when I'm writing things, I need to write them in a continuous memory. So that's the problem. It has to be a continuous memory. All right, so let's go ahead and implement the stretch buffer then, super quick. So yeah. So it's gonna be useful for BMR. Okay, so we're gonna start with, again, size and capacity. All right, char the actual buffer, or maybe I'm gonna call it a data. So, and following zero initialization rule, this has to be a valid a buffer. Okay. So, and one of the things we want to do here, we want to write some data into the buffer, right? So it's going to be buffer, and so we're going to provide the data, and we're going to provide the size of the data, right? And this thing will automatically like stretch when we write there. So yeah. And the way we're gonna actually approach that, so if buffer size plus size greater than capacity, what we're gonna do, I wanna basically buffer expand, maybe buffer resize. I'm gonna provide the buffer and the capacity. It actually has to be buffer capacity here. Buffer capacity. The capacity has to be twice plus size in case we cannot cut it. Right. So yeah, essentially after that, this particular call will guarantee that we have enough data to actually put there. And what we're gonna have there is buffer data, mem copy. Right, so data, so this is the destination and the source is going to be data, and this is how many we're going to copy there. And then we're going to have a buffer size, size plus size, and there we go. So we wrote some data into the buffer and it automatically will stretch itself, but we need to implement a special function for that, right? So it will accept the buffer, then, yeah, it will accept a new capacity, okay, so what we're gonna use here for the new capacity, so we probably can use something like Verilog, yeah. So for this particular case, I think Verilog is okay, right? Because we need to maintain the continuousness of the buffer in which we're writing. So this is going to be the data that we're reallocating, and we set a new capacity here. Since we have a new capacity, we also kind of have a new data. All right, so this one is going to be new data. So here's the reallocation. So new capacity, new data, and I might as well just reset everything. So size is going to be the same. Capacity will become new capacity, and data will become new data, which probably means that I can probably inline it if I do something like this, right? I can just inline this stuff like that, and furthermore, maybe I can just reuse the original capacity then here. Yeah. So what's cool about Verilog? What's cool about Verilog is that you can put a null there, right? Yeah. So if pointer is null, then the call is equivalent to malloc. You see? So that's pretty cool actually. So it allows you to have null as your initial buffer that you're going to be stretching without allocating or pre-allocating anything. And you just keep increasing the capacity and just reusing that. So you don't have to have any special cases, whether if you're null or not, just use Verilog with null. And it will just act as a malloc, as a first allocation. So it's pretty convenient. Which makes it possible to write stretching buffers like that in C. Quite often I saw people overcomplicating this functionality, but it's actually as simple as this. Hamikovi, welcome to the stream. How are you doing? Alright. So what I want to try to do, I want to try to maybe write something there. So we might as well also implement something interesting like write sister, right, which uses C strings. So buffer resize is stateless, cool. What do you mean? It stores its state in the buffer and it modifies the state of the buffer. How is that stateless? But again, depends on the definition of stateless, maybe. But sure. Alright. So, and here we're gonna have buffer write, buffer sister strlen sister. There we go. So that will enable us with just writing the C strings. I mean that you execute the same code whenever you call it. Oh, I see. Yeah, stateless is not really a good term for this particular case, but... So basically, it's better to put it this way. Null data is a correct buffer, is a correct data for the buffer, right? It's not inconsistent state. It's a correct one of the possible states. Idempotent, maybe, not sure. All right. So buffer, right, sister, buffer. We're gonna put hello here, right? So that will allocate exactly 5 bytes at first. And what's interesting is that at world, then it will double the size. You see, initially capacity is 0, so that means this is going to be 0. So the first allocation is going to be equal exactly to the size of the data you put in there. The next allocation is going to be actually double of that size. The next one is going to be double of that size, and so on and so forth. So, and the more you write there, the less allocations over time you're going to be doing, because you're, you know, growing like not exponentially, but quadratically. Not really quadratically, but yeah. So you're increasing the, yeah, I think it's a quadratic reallocation. So, and then, I don't know, we can actually put more things in there just to see how it acts. Full bar buzz. And then maybe to satisfy things like Valgrind, right, because sometimes I need to debug my things in Valgrind, I want to be able to clean everything up. So what I'm going to do here, I'm going to just do void buffer free, right? Or, yeah, by analogy with... oh shit, wait a second. Protection money. No, wait. It's not, it's a different one. You actually donated, make 2 donations. By the way, thank you for the previous donation. Zozin, why is your Patreon, I don't know how to pronounce that word, to be fair, I just wrote page paused. Because I'm not uploading anything on YouTube so far. So essentially, here's my policy. If I didn't upload anything on YouTube for this month, I pause this month. Yes, if I uploaded something this month, I actually don't post this month. Patreon, okay, so yeah, thank you so much. Yeah, so that's why it paused. I'm sorry. Maybe I shouldn't pause it. All right, so the reason why I paused it is because I was thinking that it's for YouTube. It's for my content on YouTube. But I could keep it as one of the options to support me. For people who don't want to support me via Twitch. I don't know. I'll see what I can do. But yeah. Sorry. Yeah. Actually, like maybe there will be tier on Patreon that gives the same perks as the Twitch subscriber on Discord. You know, streaming and stuff. Yeah. Yeah. Thank you for bringing my attention to that. I think it's something I need to think about. Alright, so I want to implement something like clean, right? So this is a buffer. Do you add the size of the new data just in case the initial capacity is very small? When stretching the buffer, do you add the size of the new data just in case the initial capacity is very small? Yes, because the initial capacity is 0. It's supposed to be 0. It is very small. Yeah, does it make sense? Because you create buffer on the stack like that. You just 0 initialize it, and it has to be a valid buffer. According to my beliefs. So it's purely religious reasons, right? So according to my religion, all of the structs that are 0 initialized have to be valid structs, right? So yeah, and yeah, so that means the capacity, initial capacity, has to be a valid capacity. So you have to deal with that, and the easiest way to deal with that is just to add the size. And on the next reallocation, you're already gonna have something that you can double. You cannot double 0, but that size ensures that you will have something to double in the future. Yeah, I will totally use that if that means still getting perks and you're getting more cut. Okay, so I'll think about that. Yeah, I'll think about that. Thank you so much for bringing the attention. Alright, so I want to be able to clean the buffer, and cleaning the buffer should be actually pretty straightforward. It just sets the size to 0. Right? Set the size to 0, and you can just reuse this memory. So this could be a different kind of allocator, but you cannot really... It's not even an allocator, right? Because it doesn't allocate anything. You cannot rely on the pointers for this allocator because we constantly reallocate everything. So basically, if you have any pointers, if you if you've taken any pointers to this particular data, at any point they can become invalid because the data can be moved to a different place because we need to maintain the continuousness of this buffer, right? Right, and another thing, if we want to basically free the memory, right? If we want to free the memory, I want to do the following thing: buffer, right? So it's going to be just free buffer data, and the question is free of null a valid thing? If I remember correctly, free and null is a valid thing. This is not what I want. It's free function. If pointed, no operations performed. Yeah, basically you can literally just do that and then buffer free, and it's not going to be segmentation fault or anything, right? Because freeing a null pointer is a valid operation, right? And also null pointer is a valid empty buffer for reallocation. So actually, in that regard, C library is designed quite well. Not all of the places of C libraries or C library are designed that well, but realloc and free are more or less usable. So if you want to have these stretching buffers and whatnot. All right. Okay, so in this case we can set the size to 0. Maybe we also want to set data to null, size to 0, and capacity to 0. So basically then later you can reuse it again, right? So you free this buffer, but then you can reuse it. And we can put this buffer free in here. There we go. Cool. So this is our small buffer that we can put into BMR because this is where we're going to collect the output of the program. Let's see how it's going to work if we compile it. So we don't have a free, don't have a realloc. Let me include stdlib. Don't have anything else here. So memcopy that I think requires string, if I remember correctly. So sister. Discards const qualifier. Oh shit. Okay, one of the things we can do here actually, we can say that we accept const here. Yeah, we can accept const because this thing does not modify the memory, so there's no reason to modify any of this memory. Yeah, that makes sense. Okay, so this thing doesn't really print anything, so the only way for us to check if it works correctly is to look through a debugger, but to look through a debugger we need to compile it with the ggdb. Okay. Break main run to enable. Let's print the buffer, and there we go. So we didn't zero initialize the buffer yet, but now if I try to print the buffer, it looks okay. So yeah, I can try to display the buffer, but I don't think it's gonna actually show anything particularly interesting. Yeah, and look, I'm pushing the value there, and it allocated 5 bytes as the first initial capacity. Okay, that makes sense. Oh, it even prints the string, which is nice. All right, that's pretty cool. So we're gonna make another step, and it replaced with a world, and we found a bug. Yes, it keeps. Okay, it keeps replacing it because I think I forgot to do a very important thing. Essentially, where I have to write into the buffer data plus buffer size. There we go. So that's why it's quite important to test this kind of data structures in the debugger, just to see if they do exactly what you want them to do. Am I right? Am I right? So yeah, classic. Let's recompile this entire thing and rerun, break on main. Run to enable, and also print the buffer, and let's see how it's gonna go. So I didn't want to print it, I actually wanted to display it. Okay, so here is the hello, then we have world appended there, then we have foo appended there, bar, buzz, and after free, everything has to be freed. There we go. Furthermore, if I run it, right, in Valgrind should say that there should be no memory leaks, and yeah, so all heap blocks were freed, no leaks are possible. So if you free this buffer afterwards, everything is working as intended, and you have a stretchy buffer that stretches over time. By the way, in terms of capacity, I forgot how capacity grew. I want to see how the capacity grew. To enable and display buffer. Okay, so capacity was initially 5. then capacity was 15, then it stayed 15, so you see on the third one we didn't even do any reallocation. Then there was another reallocation in a double the size, and then we were not going to have any reallocation for quite some time. So, and then we freed everything. Okay, that looks cool. So it would be cool to pre-allocate something with a big buffer, but I don't think it's required. Like after a few reallocations, it's gonna basically stabilize and don't do too many reallocations, I think. So it's a quadratic amount of reallocations starting from 0. So yeah. Okay. Was it useful? I can also upload that to the gist if anyone needs this buffer. So I can do the same thing as with the region-based allocator. Right, so for the region-based allocator, we have this thing, right? And for the stretchy buffer, I'm gonna create another gist. Are these data structures useful for anyone, right? So I hope they are, maybe they are. It's like C is so bare bones, you have to implement these kind of things yourself, right? In other languages, you probably have something in the standard library. In C, they just throw at you realloc, and you can do whatever you want with it, right? So try to survive. They just throw you in the waters, do whatever you want. And that's exactly what we did, by the way. We survived. Anyway. How to make a gist? I forgot how to make the gist. Yeah, so it's gonna be main. Stretching buffer in C. So I'm gonna create a public gist. Boom. Excuse me. And yeah. Why Rexium on GitHub and not Tsoding? Because Tsoding is not my nickname. It's the name of the project. The goal of the project is creating recreational programming content on the internet, and Rexium is my nickname. But nobody uses it, so... Except you, because you asked this question. On the internet, yes. We are on the internet. Did you know that? Did you know that we are on the internet? Amazing. I also like the simplicity of this implementation. It's just actually super simple. So usually when people need to implement something like that, they overcomplicate this kind of thing, but you don't need to. The corner cases of realloc and free make it super easy to implement it in a very simple way. The information superhighway. Yes. Alrighty, so we have a buffer, which I could probably now try to integrate into the BMR. So first I'm gonna actually put it only into BMR, right? BMR is the, virtual machine recorder. But why is your Twitch name is not Rexium? Well, for the same reason. Okay, so we have a buffer now. So this is free, and what I'm thinking is that I probably should allocate that in a static memory. So it's going to be static buffer. We're going to call it write buffer, and we're going to zero initialize it as well. So this entire thing is going to be located in BSS, hopefully. I'm working on the convolutional neural network, I think. Have you written anything similar? I wrote simple neural networks in Haskell from scratch, but yeah, I don't think it was a convolutional one. I was just, playing with things around. Anyway. Oh, I remember Cache actually showed me a pretty cool library in C. C Dark Web, I think this is what it was called. Or Darknet. I don't remember. Was it Darknet? Yeah. Darknet is a convolutional neural network in pure C. Yeah. So imagine that in pure fucking C. That's so cool. I wanted to check it out at some point. Look. Also uses CUDA and pure C. Fucking pure C. Yeah, because like everyone these days does this kind of stuff in Python, and somebody actually decided to do that in Purely C, and why not? I mean, that makes sense. It makes it easier to integrate with such things as CUDA, right? It makes it easier to like go even faster because you get closer to the metal. So it does make sense to do this in this kind of languages. It's just like these kind of languages are rarely taught for people who are doing any neural networks. So yeah, it's pretty cool. I think I'm gonna give it a star. I think it's a pretty cool project. Yes. C have no limit. This is not true. How do you explain this shit? Destroyed with facts and logic. I'm sorry. Python has no limits. Really? They don't have? Alright. Well, Python is used to... Yeah, it's primarily as a glue code. So the entire, for example, like TensorFlow or PyTorch, as far as I know, they're written in C++. I know for sure TensorFlow is written in C++, but I'm not sure about PyTorch. Let me actually check it out. GitHub. I've been old, I'm sorry. Yeah, fucking look at that! 53% of C++. None of these neural network library, Python neural network libraries are written in Python, right? They just have a Python interface. Well, to be fair, they're not necessarily like... yeah, they... libraries. Alrighty. Oh, I just remembered how Casey was trying to build TensorFlow on Windows. That was the most entertaining stream from Casey I've ever watched. It was so fucking cool. I'll grab this Python and go to old Fortran 90 code. You don't have to. I'm just saying facts. I'm not saying what anyone who has to do. I'm just saying straight up facts and nothing else. And these kind of facts are not even that useful, so whatever. Okay. So BM, right. Let me try to compile this entire thing. I already compiled everything. So let's do no build. Okay. Buffer resize, no previous prototype. Okay, this is because I want to make it static. I'm gonna make all these things static. Everything is gonna be static. All right. Anything else? Arena alloc. So when you're writing something, right, we just take a chunk. Alright, so maybe instead of doing that, what we have to do, we just have to do buffer write. We're gonna use our write buffer, then we're gonna take the memory at that particular address, and the amount of bytes we're gonna write into that buffer is the count. And I think we can straight up just remove this entire thing, so we don't need to allocate anything in here. And yeah, so this is gonna be this is how simple it's gonna be. All right, anything else? So pointer targets in parsing differ. Oh shit. I mean, yeah. What's wrong with that? I might as well actually do it like this, and I think it's gonna be okay. All right. So now, actual arena buffer. So what we're essentially doing here, we're writing the buffer to a file. Yeah, we're just writing the buffer to a file. So I'm gonna do buffer, and this one is gonna be data, size of a single thing here, and we're just writing everything to the file. Next problem. Oh, it has to be right buffer. It has to be right buffer. Right buffer, and I still have to split everything. Okay. Alright. So the next thing we're trying to do here, we're trying to convert actual arena to the string view. So instead of doing that, I think I'm gonna have a special function, buffer to string view. Right, so it's gonna be buffer, buffer, and it will return you a string view on that specific buffer. And it should be as simple as returning string view, where you have a count equal to buffer size, and the data, if I remember correctly, I think it's equal to the buffer data, and that should be pretty much it. Right, so just a string view on that specific buffer. Okay, so it's a pointer. Disappointer. Okay, so write buffer, buffer to SV. Oh my god, Emacs, stop. Stop. Please, no more. Okay, so we have things like buffer free is never used, which is kind of interesting. So we don't need clean, so I'm gonna remove that. We don't use write sister in this particular case, but I think we're gonna use buffer free at the end of the execution, just in case, because why not? So we don't really have to do that, because the operating system will deallocate all of the memory for us anyway, but why not? Yeah, right buffer. Alright, everything compiled. Okay, that was interesting. So we don't have to do anything else anymore, except in the places where we use the arena. Alright, because now arena is something that you have to not forget to free. Yeah, let me try to run the tests and see how it goes. So this is going to be the test, and test should go okay. Yeah, test went okay. So so I'm gonna go to the BMR. Actually, I don't want to call it a write buffer. I want to call it actual buffer because it contains the data that was actually printed by the program. So this program specifically, what it does, it runs your program in a virtual machine, collects the whatever the program prints and collects it into a buffer so we can compare it for testing purposes, right? So we use it for testing things. And that's why I want to call it an actual buffer, because it collects the actual output, not the expected one, but the actual one. So I think it makes sense to actually call it like actual. Yo, what's up, Anabosu? Hello. Hello. We're writing some dynamic memory allocation shit. How about that? Yeah. And integrating arena allocators. So it's pretty exciting. So we just wrote this stretchy buffer thingy. So it's just this structure, and we constantly use realloc to push more data into that buffer, and then we can do something with it. It's pretty cool. Reallocation of the whole nation. Okay, whatever. So what do we got? So yeah, and it doesn't even break anything. All the tests pass, so that's kind of cool. But the problem is that in all the places where we use the allocator, we don't really free the arena, and I'm thinking, do we really need to do that? Do we really need to do that? I don't think so. So let's actually just go ahead and do a committee, and maybe even pushy. Alrighty. Integrate region-based memory allocator as an arena, as the arena, right? So I'm gonna push that right into the repo. Brazilian government leaked highly sensitive data from more than 223 million citizens. Even dead people data was leaked. Interesting. The more I read about Brazil, by the way, the more it sounds like Russia. I think we already talked about it with Nuligor. Yeah. So basically, Brazil is a South American Russia, or Russia is basically Eurasian Brazil. In terms of, like, you know, how fucked up the government is. Almost, yeah. Alright, let's create the pull request. Integrate region-based memory allocator as the arena. Close 154. And, yep. There we go. And while it's doing its thing, I want to make a small break, chat. I really need to make a small break. I'm really sorry. It is what it is, and it isn't what it isn't. 3 minutes, I think, should be okay. Minuta. Whatever. Minusa. Sure. Alright. Let's make a small break. You guys have fun? I said. There we go. Hugh Vilk. So let's continue. Yep. Oh shit. Of course. Would you look at that? Would you fucking look at that? Windows broke. Let's take a look at what is it this time. Process completed with the exit code 1. Thank you. Very cool. Oh, okay, so here's the error message. The following warning is treated zero-sized array in a struct union. Okay, that's very interesting. vm.h 214. You fucking serious? You fucking, oh my god, it doesn't support flexible array members. Oh shit, my entire allocator is based around flexible array. I forgot Microsoft Visual Studio doesn't support that. Ah! Why? This is such a useful feature. Why? So essentially, for those who doesn't know what I'm talking about, the latest C has a pretty cool feature called flexible array member. Flexible array member, right? You put like a unsized array member at the end of the structure, and it extends over the structure, right? So, and it basically makes it possible to have like variable length structure. It's a C only. Oh, so basically, Microsoft Visual Studio does not support C only things. God fucking damn it, mate. God fucking damn it. Well, but the problem is, I cannot just, you know, do things after the struct. Yeah, MSVC only supports Windows. God fucking damn it. I wanna cry. I wanna cry. I'm gonna go make a cup of tea. I'm gonna go make a cup of tea. I'm upset. Fucking upset. Ah. And now I have to redesign my entire allocator. Fucking classic. Well... Allocator stream again, yeah, exactly. Why can't Windows people use GCC? They cannot. It's not about like forcing people to use a specific compiler. It's about if you want to use this compiler, which is pretty popular by the way, you can use it. So yeah, we're trying to support like as many popular compilers as possible, or at least write the code that works on as many popular compilers as possible. Okay, so maybe we can have an example on how to do that without. Watery1, I hope I pronounced your nickname correctly, gifting a tier 1 sub to Sodium community. Thank you so much for gifting a sub. Thank you for supporting the community. And Atlanta Jose, I hope I pronounced your nickname correctly. Welcome to our epic flexible array member club. It's a flexible array membership to the... Sorry. TCC is quite popular. Oh my god. Well, I mean, to be fair, TCC sounds more like a meme rather than a compiler. So yeah. Flexible array members were officially standardized in C99. However, the compilers accepted zero-sized array members with the same effect. Flexible array members are not officially part of C++, but the same compatibility extension exists. Wait! It does work on MSVC, it's just it throws a warning. Non-standard extension. Can I suppress this shit? So warning C420. 420. 420 warning. What is this? Is this how you suppress it? I want to suppress this specific one. Okay. Nice. Pragma warning disabled for 20. Okay. That sounds pretty feasible. I literally put it like here. And I wonder, will it compile, like for example... It generates another warning, sure. Maybe I can disable it on the level of a flag. Okay, MSVC disable warning flag. Okay. So ignore. If def time. Maybe if I cannot find the flag, I can do if def. It's just I'm not sure how to ignore things. No build C. So we have a bunch of shit in here. I think it's WD, isn't it? I think it's WD. Yeah. WD. Suppress the compiler warning. Okay, perfect. I found it. So it's gonna be WD 420 blaze it. There we go. Cool. Oh shit. What is going on? Emacs. Cool. Suppress MSVC warning about flexible array members. It's a standard feature. God damn it. Okay. I'm not sure how to ignore things. Ignore chat for 3 hours straight, yes. I mean, is there any flag to ignore the chat? Oh, I know. There is a flag. And it also involves W. The flag is Control W. Sorry. Anyway. Isn't that epic? That's a pretty cool flag. Not gonna lie. I'm sorry. It was a joke. It was a joke. We have a cup of tea. Let's wait for the continuous integration. I wonder in how many places this entire shit will fail. Alright, so yeah, the thing I'm interested in, will it work on ARM 64-bit? So maybe at some point Hihots and Pots will check it, I don't know, maybe. Another thing, right now, if you try to run the emulator, Out9, what's up? What's up? What's up? Welcome. Alright, so what am I doing? If I try to just run the program, right? I'm just trying to run the program. It's going to bin CVM, why not JVM? So if CVM stands for custom virtual machine, JVM stands for just virtual machine, just virtual machine forehead. All right. Build bin BME, and there we go. Java virtual machine. I see. That makes sense. Example and a fib BM. Right. So there we go. Looks pretty cool. But if I do valgrind, it will tell me that I leaked a bunch of memory. Or did I? Actually didn't leak any memory. That's cool. Probably because the BME does not use the arena allocator. That's why we didn't leak any memory. But I do know what uses the arena allocator. Bosom. So it's going to be build bin bosom. There we go. So, and you have to provide the input for this entire thing. So the input in our case is going to be example, right? And it's going to be fib bosom. And you also have to provide the output. So BM. All right. So that created the BM file. And now if I'll try to run this in valgrind, it will tell me that, bruh, you leaked a bunch of memory. So yeah, 11 kilobytes was leaked. Please don't tell Fengchi, but I leaked some memory. But it should be easy to fix, actually. Should be easy to fix. So you basically go to bosom, right? And inside of a bosom, you have an arena, right? You have an arena. And essentially, you take bosom arena, and you just do arena free. You free the arena, and you're free to go. How about that? You just free the arena. And now, if I try to run the valgrind on this entire thing, all he blocks the freed. There we go. So yeah, arena just allocated a bunch of stuff, and yeah. Another interesting thing, I want to kind of see the structure of the arena after the translation, because I think it's going to be interesting, right? So how many pages it's allocated, how much of the pages were filled. So let's take a look at that. So we can do something like, do we have like a print summary of the arena? Oh yeah, there is an arena summary. Arena, oh my god, arena summary, Bosom arena. We're gonna just do that right before we free the arena, so we don't lose any information about that. Oh shit, that was interesting. Okay. And this is because the arena doesn't have a default capacity. Yep. I'm really glad I decided to actually do that. I think I learned about Go like defer implementation in C. Link to the shortcut is at the bottom of the page. Okay, let's take a look. Sounds interesting. Interoperability with C++. Alright. C++ has... I probably need to make it a little bit bigger because I can't reach it. C++ has a similar feature of out-of-order code execution, namely destructors and catch clause. The defer statement combines those two into one. This implementation provides feature to translate between these mechanisms, such stack unwinding. It can reliably. Okay. So at the bottom of the page. All right. Can be found. Defer C. And how do you define even defer? Oh, that was... So there's a std defer. Std defer. Too much text. It's probably something like define defer. Yeah. Found it. Holy shit. Well, I mean, there's no even escape in here. Oh, that's too much code for such a simple feature, to be fair. So yeah, I guess essentially that's what's happening when you're trying to fix a flawed language, right? So you're trying to add a feature that has to be inside of the language compiler, but you're trying to put it outside, and that's the result. Yeah, it is not simple. But doing that from within the compiler would be actually easy, I think. But yeah, you cannot do that in C at this point. Okay, it's pretty cool. All right, so yeah. Okay, there is a problem in here. So arena, you have to set the capacity of the arena first. And I'm thinking, do I really want to do it this way? Maybe. So in Bosom, essentially, you need to set the capacity of the arena first. Where do we allocate a Bosom thingy? We allocate it here, actually, and I can essentially put it somewhere here. So it's going to be arena, right? And inside of the arena, capacity of the arena is going to be 440, right? Something like this, right? So this is going to be the initial capacity that can be used. And let's give it a try now. And yep. And so far, processing any of this stuff, it never allocated more than needed. So which is kind of cool. All right. So one of the things I wanted to do, I wanted to go through all of the places where we have this kind of arenas, right? And basically set their capacity, and also free them. Right, it's not going to be particularly necessary, but I think it's going to be useful nonetheless. Yeah, we'll see how it goes. So, bosom.h, so it's going to be bm.h, and I already removed the arena default capacity. Arena, there we go. So we create a region, and so on and so forth. Let's define arena recommended capacity, and it's going to be this capacity. There we go. So arena recommended capacity, and inside of the bosom we're going to just use this thing, arena recommended capacity. Cool. So bosom to NASM, do we have a bosom in here? We do, actually. So arena capacity, arena recommended capacity. Yep, I think that's about it. And after that, we want to do arena free bosom arena. I think we don't allocate anything anywhere anymore. Yeah. So in bosom we did that. BDB, I think BDB does set arena. It does use arena. Yeah, there we go. So arena capacity, arena recommended capacity, arena free. So do we even have a bosom? I don't think we do. Okay. So BME doesn't use arena right now for emulation. It doesn't use that. Here we do. I'm pretty sure we do use the arena. Yeah. Okay. So that makes sense. Well, no, we don't. BM doesn't use that as well. Debosom. What about debosom? Debosom also doesn't use that. But when you load in program from file. Oh, okay, that kind of makes sense. Okay, cool. All right, let's try to compile everything and see how it goes. So it's gonna be no build test. And BDB, it's called BDB state. Is it just called state? I don't remember if it's called state. It's not called BDB state. Is it just called state? BDB, yes, it's just called state. Compatible type. Okay, cool. So, and in a place in BMR, we free the buffer, but I think we forgot to also free the arena, right? So, do we even have arena? Expected arena. Oh shit! Yeah, we do need to free the arena. Oh, hello, Jiang. Welcome to the stream. How are you doing? Arena free expected arena. So do we do arena? Yeah, that's the only arena that we use here. So that arena is needed to slurp the files. You can just create it and then you can free it, and yeah, there we go. So that's pretty cool. So we have buffers and arenas and whatnot. Pretty interesting. Okay, so we ran the test and everything looks okay. Um, free the dynamic memory allocated by the tool chain. And I'm gonna push that right into the repo. So I think that's it for this specific issue. We finally managed to integrate the arena into the tool chains, and yeah, that's pretty cool. Yeah, we can now basically keep allocating as much memory as we want. It dynamically grows, it dynamically creates new pages, and we don't have to worry about pre-allocating too much static memory for platforms like Windows or ARM64 or whatnot, right? Because it's not going to allocate that much memory upfront, right? So essentially it will just allocate first the first page and then the next page, so it's going to grow gradually, and then it's also will make it possible to reuse that allocated memory in the future. So yeah, I think it's a good thing. All right, so let me now merge everything. Is it okay now? Let's merge the pull request and delete the branch. Okay, cool. So this one is done. So let's go to the master and finish the other stuff. All right. So what's going to be the next issue? I think I need to actually write something to this issue. Implement some instruction. So I need to take a look at what I was doing here. 154. Error allocating memory. Oh wait. Oh yeah, it's a completely different thing. I see. So yeah, this should be okay. So segmentation fault is related to not implemented instructions. So this is a completely different thing. Examples do not work on Mac OS, x86. Succeed even when it actually fails. I'm not sure if it's true right now. I think it does not anymore. I'm gonna put, mark it as invalid. I don't think it does anymore. I don't really know why though. So I'm gonna just close the issue. Right. So close the ticket. Remove the string length hack from ROT13. Wait, I do remember that. After 7, yeah, this is something that I want. Yes, this is what I wanted to have for quite some time. Right. So essentially, I wanted to be able to use this kind of directives to get the length of the strings, and I didn't implement it first. Okay, that's very interesting. All right, let's just go ahead and do that. So essentially the problem is that, for example, in a ROT13 example, you allocate a string, and the only way for you to know the size of that string is to allocate another one after that, right? And the address of that string is going to be after that address, so you basically subtract the original address from the new one, and this is how you get the size. But the problem is that you have to do that at runtime, right? At runtime you will have to literally push first this thing, so you will have to do something like push secret and then you push secret and then do minus f, right? And you're essentially wasting cycles and whatnot, right? It would be kind of nice if you could just push length of the string, because the compiler, the translators, knows the length of that string, right? It's yet another situation when the compilers knows some information. It's just there's no way for the programmer to get that information, right? So, and we need to introduce the ways of getting that information, in my opinion. So what I'm thinking, so the idea was actually maybe introduce another label with the names secret length, secret.length, and yeah. So that's actually kind of cool idea. I like it. So it basically kind of implies that you have properties of certain values and whatnot. Properties of certain values. Yeah, I think I'm gonna literally do that. So we have secret.len, and essentially when you create a string, it creates two labels. It creates secret and it creates secret.len, and secret.len contains the size of that string. I like the percent directive option. What? Cool. I'm really glad that you shared your opinion. Thank you so much. Okay, let's go ahead and implement that. There's no way to get the size. 77. All right. So 77. Nice. I also want to be able to maybe at some point have like actual mathematical expressions, because I want to be able to do things like const n, alright, and then push n plus 69, and I want these kind of expressions to be executed at compile time. I think it will be kind of cool. So essentially you would have like a simple compile time language, right, on top of the assembly that have these mathematical expressions, right? These mathematical expressions are not runtime expressions, but they are other compile time expressions. But that will require like taking this entire thing and parsing it into AST. And what's funny is that some of the variables here may not be actually defined at the time of the translation of this specific instruction, so you have to defer evaluating that expression to the second phase, similarly how we defer evaluation of the labels to the second phase, and then go through all of these ASTs and evaluate them after all of the labels are available. So yeah, that's pretty cool. And yeah, sounds like a pretty interesting thing to work on. So do I have an issue for that? Good luck. Good luck with what? You think it's going to be difficult? It's the difficulty of this entire thing is similar to difficulty of evaluating labels, right? It's just instead of deferring label evaluation, you defer AST evaluation. But it's the same thing. Like you're still doing the same thing. You're still doing the two phases anyway. It's just like instead of one type, you have another type. So we don't see anything particularly difficult here. Oh, he's just giving me. Okay, I see. Thank you so much, by the way. Thank you. All right. I thought he's been like sarcastic, saying that like, good luck with that, buddy. All right. Anyway. So what do we got? Compile time math expressions. So I'm gonna put bosom in here, and this is gonna be a simple example, right? 420, then 69. Yeah, this should be a thing, right? And we can implement it at some point. Doesn't support bosom. GitHub. Why are you not supporting bosom? Disgusting. Anyway, what I was working on, I don't remember. don't remember what I was working on. Something. Oh, I cannot even go back. Oh, length. Yes, length of the instructions and whatnot, and length of the strings. All right. To have a length of the strings, I need to. I don't even need to keep track of anything, actually. Translate literal. So we are translating strings in here. Right. So here's a string. And yeah. So it gives us. So if it's a string, we are doing this. SV data 1. Ah, I see. So you're just translating the literal. Okay, so after that, you translate the literal. But what do you call the push string? Push string to memory. Right. When you push a string to a memory, right, it just pushes it and gives you the new thingy. All right. All right, this is where we do that. Okay. But after that, how do we assign a new label to it? This kind of thing makes it difficult to create new labels in the same place. So that probably means that we'll have to change the logic behind this thingy. Okay. Translate literal and the value of the literal. Push string to memory. Wait a second. Const. Yes. I see. So basically I need to know what it was. I need to know the type of the string literal afterwards. That makes sense. So maybe we can actually have the kind of the literal. We can have the kind of the literal. Because we have several kinds of the literals, like the translator rule actually knows about this kind of stuff, right? So it has a character literal, string literal, hexadecimal literal, integer literal, right? And a floating point literal. And we need to basically be able to distinguish between them. So what I'm thinking is that we need to introduce the type that actually lets us, distinguish between them and communicate between different parts of the code about like what's the literal, what kind of a literal we have there. I'm also starting to think that maybe we should separate the headers for BM and BOSM, right? Because yeah, sometimes if it's gonna be like a header on the library, you may not want to bring like the whole assembly. You only care about virtual machine. So, and BOSM could be something that is built on top of the virtual machine. So yeah, that actually sounds pretty interesting. But in any case, where is the BOSM definition? So here is the BOSM. We have deferred operands and we have different kinds of bindings and whatnot. And maybe I'm gonna introduce type def in num literal kind. So what kind of literals can we have there? All right, so we can have a literal char. Literally kind, yes, literally kind. String. Char string hex int Maybe, yeah, maybe deck, I don't know. Or maybe int, let's just call it int. And the last one is float, right? So this is the kind of literals we're gonna have there. Maybe we're gonna do the following thing: translate literal, and it's gonna return us the literal kind, like the literal kind. And to indicate that it couldn't translate the literal, right? It couldn't translate it. The literal kind will also have invalid one, invalid, like this. So it's gonna be 0 by default. So this thing is gonna be invalid. Alrighty. Metaphorical kind. God damn it. So invalid literal. All right. So I'm not sure how good of an idea this is. Translate literal, but maybe it is. Yeah, and it's kind of cool that it also creates a completely different type. All right, let's try to compile that and see what's going to happen. So literal kind. All right, and it compiled for some fucking reason. Thank you very much. I really like how it just compiled. All right, thank you, C. Very cool. Because this thing is not different from Boolean, right? So yeah, it will just, of course. Thank you, C. Very cool. I want to make another cup of tea, but I already had too much caffeine for today, so... So one of the options that I have is to just rename this entire thing and let it fail in all of the places where is it? So, yep. Well, in here, so in this particular function, we don't return true, right? So, yeah. So this maybe will require changing some things, I guess. Literal invalid, literal character. So this one could be literal string, so like this. This is literal hex, literal hex. So this one is slightly so if this thing is not equal, this is kind of a dumb thing. If we succeed doing that, okay, so if we succeed doing that, we can just do else, right? We can just do else and return literal integer, right? So this is just literal integer. So this one literal invalid, and otherwise this one is a literal float. All right, so literal invalid. So okay, literal string. Okay, so this is a hex. Okay, this is a literal invalid. Literal invalid. Okay. Cool. So now let's try to go through other places. So what is this? This is a const. Nice one. Is not a number. Nice error message, by the way, because literals are not numbers anymore. Yeah, so this is an old, very old error message. And it comes from the days when you can also only bind numbers. You could only bind numbers. I'm gonna make a small break, chat. Alright, let's make a small break and you guys have fun. All right, so let's continue. So we have this thing. So this is a literal and literal kind. Right, so here's the kind. And if the kind equal literal invalid is not a valid literal. There we go. I think it's a little bit better. If it's this, then we're trying to bind a value, right? Trying to bind a value. So this is going to be a location. So this is the name that we're binding, right? And the name is the... Okay, so the name is that thing. All right. So we want to actually bind another one. And surprising thing for me, I think we spent too much time handling this entire stuff. Right? Because why can't bosom bind value actually report that shit for us? Because look at that, like we're repeating this entire thing like literally everywhere. So maybe this kind of reporting has to happen inside of the boson bind value. Yeah, that would make sense. Except when you do need something from the context of boson, but we do pass the context of boson. So yeah, it would be just easier to, you know, just run that and forget about it. All right, but I already doing some things. I don't wanna. Yeah, I'm in the middle of refactoring and I need to do another refactoring, so that's kind of dumb. So what I'm thinking is that maybe I'm gonna just put it to do here. Make boson bind value report the already bound error. Right, you know what I mean? So, and then I need to bind another value. But only if the kind is a string. If the literal kind, a string, right? Only then I need to create another binding here. I need to create another binding. Right. I need to create another binding, and the binding is going to be just basically concatenation of the name and plus dot len. So I need to concat name and dot len. So, and I think I do have functions for that. I think I do have that. So I think it's called something like arena concat. Or maybe arena is... Yeah, there we go. So essentially you can take two sisters and concat them together. Which is kind of interesting. So, but we don't have a way to concatenate some other stuff. So we need some sort of a function. Yeah, these concat functions are useless. So I need a string view at the end. So what I can do, I can just convert one of my SVs to the string. Oh. Or maybe I can just... I could just have another one, right? Another one that accepts these two things in here. String view. But it's already like that. How should I call it? I'm gonna maybe call it SV concat. So I definitely need to refactor the concatenation functions here because they don't really make any sense. So yeah, I need to implement this entire thing. And again, this is another refactoring. Really, like I'm in the middle of refactoring and I hit some bad spot that I also need to refactor, but I cannot because I'm in the middle of another refactoring. It's just, oh my god. Oh my god. Alright, so make arena concat functions more universal. Whatever is that supposed to mean? I don't know what is that supposed to mean, but this is something that I need to do here. Hello 7muddy06. And yeah, so I just need to implement this thing. God damn it. To do. Alright, so to sister. So I'm gonna put this thing down below. Okay, so to implement that, what I need to do, I need to allocate a new buffer here, right? So it's gonna be a buffer, arena alloc, arena, the size of A, count, plus the size of B. We don't have to do +1 because they are not null-terminated. I've seen that clip. Okay, memcopy buffer a data. Yeah, so it's we're copying that from there, and we're copying exactly all these things, and then it's going to be a count, and this one is going to be just B. There we go. Cool. And after that, we need to return string view, where count is a count plus b count, and I think it's just data is the buffer that we're like doing here, and that should be the concatenation we're looking for. All right, so we have this thing, and where is another to do? Here it is. So, yeah, now I should be able to do the following thing. I should be able to construct a name length. So it's going to be name len, and it's going to be arena svsv concat2. So you provide the name, which is already string view, and I can create another string view sv from sister, and it's going to be just .len, and that creates a new name for the binding that I can use right here. It's going to be name len, and then I need to rename this to just len in case already somebody took that. So yep, that automatically does whatever the fuck I want to do. You have a buffer to SV. It has nothing to do with what I'm doing right now. Okay, so translate literal. Implicit declaration of bosom translate. Oh yeah, so this one is fixed. Okay, so I also have to provide the arena. Bosom arena. Well, you're just making too many assumptions. I would really recommend, while watching my channel, not to make too many assumptions about what I'm doing. Because people in 60% of the cases are wrong about what I'm doing. Completely. Like, absolutely fucking wrong. So, okay, we're creating a native function. And this one is interesting. So, so it could be just a number, but apparently you can also assign. So all of this stuff needs to be refactored at some point, but right now, at least for this one, I don't know how to properly refactor it anyway. So this one is going to be equal literal invalid, right? And this one is going to be just that. Right. Okay. It's equal literal invalid. By the way, yeah. Oh shit, this is actually quite dangerous because there's like logic. Oh my god. Oh shit. So if you cannot, yeah, so it's basically the same thing. So yeah, it's the same thing. Yeah. Okay, so everything's okay. Literal invalid. Okay. Yeah. Okay. Okay, it compiles. Nice. And what the hell is going on? Oh shit. Okay, so it broke. We broke something. And we broke something to the point where it doesn't even compile anymore. Nice. Did I modify any cast functions or anything like that? So the fib actually worked correctly, but cast didn't. That's very interesting. And I didn't modify any of them. Right. So that means I did some mistake, like literally in here. That's very interesting. Let me take a look at the example itself. Cast. Okay, so this is how it looks like. Let's take a look at the disassembly of this thing then. It's gonna be build bin debosom build example cast bm. Alright. So that's very interesting. Well, yeah, to be fair, the problem can be in the compiled version of the standard library as well. But to be fair, this thing doesn't look like a proper thing anyway. Oh yeah, look at that. Push minus 420. Something wrong with the floats. Yeah, we're pushing floats and the floats were not translated correctly. Oh shit, okay, I think I know what's the problem. Translate literal. Yeah, I know the problem. So... Huh. Okay, so... Well, I just returned true on this thing and it should be okay. So this is what we're trying to do. We're translating the float, right? We're translating the float, and if it's not correct, we just return invalid, but if it's correct, we return float. So I literally don't see any problems in here so far. So that means the problem is not in here, but where? So let's take a look at all of the changes we made here. Luckily, we didn't make that many changes, so it should be pretty easy to find. Hopefully. So here's the kind, right, and if the kind is invalid, we report an error. That makes sense. But if it's a string, we do that thing. We just append a new thing there. All right. If this thing is equal literal invalid, we do that. Not invalid. Not invalid. All right. So I have an idea how to like actually narrow down the possible bug in here. I'm gonna be bug bosom, and we're gonna do something like this. So I'm gonna just push 3, 14, 15, and it's gonna be entry main. Okay, so the reason why I want to do it like that is because I don't want to include the standard library so I can clearly see. Bosom. Yeah, it didn't resolve it at all. Alright, we can try to do, you know, an actual debugging of the bosom. Actual debugging of the bottom. GDB. Right, and I also need to break in a very particular place. I need to break in a particular place, which is basically break bm.h, and I'm gonna break at the line 1394, right, and then I need to run this entire thing like this. All right, to enable, and let's take a look at what we have here. So the next step, sister, yeah, here's the number. Cool. Nice. I tried to parse that, and that didn't parse, obviously. Now I'm trying to parse that, and if I take a look at the result actually parsed correctly. So here's the value, result parsed correctly, and we're returning the literal float. So that returns from this entire thing. Okay. Yes, I found it. I think I found it. I don't know why. I don't know why it's happening. It's really strange. So when the literal is invalid, we're trying to treat it as a label. When the literal is invalid, we're trying to treat it as a label. All right, I want to make a cup of tea. Why is it happening? So it was a valid excuse me, no, so the idea was valid. So if it's invalid, we do that. So where am I exactly? So this is an instruction, right? This is an instruction. It has an operand. It has an operand. We translate the literal. If the literal is invalid, we use the thing as the deferred one. So like it should work, but it doesn't work. What did I miss here? Push deferred. So, and if I actually stash everything, and if I try to recompile everything, it will pass the tests. It will pass the test, and yeah, everything passes. And if you don't do that, right? And I didn't, like, I made something very stupid, as usual, and I cannot notice that for some reason. Yeah, there we go. And it's just like, where did I make a mistake in the logic? I cannot see that. I cannot see the mistake in the logic. So the mistake is that floats, for some reason, are treated as zeros. They are treated as zeros. They are not properly deferred or anything, even though everything seems to be okay. So I made a mistake somewhere. So false here. Literal invalid. But this one is literal hex. Literal invalid. To be fair. Yeah, I see it. I see it. Hello. Fixed it. Found it. Found it. Epic. Actually fixed it. And that cost us a lot of viewers because a lot of people were just leaving when I was struggling to find the bug. It's like... It's so funny to like look at the view count, and every time you hit the roadblock and you're trying to go deep in the debug, it's just view counts like instantly drop. Like it's just like, wow. Sure. Not allowed to make mistakes. Right. How everyone is doing? How everyone is doing? Is the converse also true? Yes, it is also true. So Yoseplots is sipping tea. Yes, it's a very good activity. I do approve of sipping the tea. Yeah, I guess people start feeling uncomfortable when you know, there is a bug and it's really difficult to find it, right? Maybe it basically brings back their PTSD at their work, right? Because yeah, once you're having these kind of bugs, you're not having fun anymore. You're essentially doing the work. But yeah, I can understand those people, I suppose. I can understand those people. Okay, so we can kind of distinguish now between these kind of things and whatnot. It's pretty cool. All right, so but the question is, debugging can be fun too, learning from the mistakes. You don't need to explain that to me. I have no idea to whom you explaining that, but people who probably need to hear that sentence, they already left. So, sorry. It is what it is. Like, it's just it's pointless to even like justify this kind of stuff because those people already left. Like, who are you talking to? Like, yeah, you're talking to nobody. The room is empty. Sorry. I'm gonna go to the kitchen and basically just turn on the kettle for my tea and yeah. Small break. 2 minutes. Maybe it's not gonna be even a break because yeah, I'm just gonna quickly go and turn on the kettle. All right, no kettle for now. So, the feature we were implementing is the ability to take the length of the string, right? The ability to take the length of the string. And we can try to do that in Rel 13. Maybe not. Maybe I'm gonna just, you know, go to a simple example. Test bosom, right? We're gonna have a test bosom. And here's the entry point, entry main. And so essentially, so it's gonna be const hello, hello world. And I want to try to push hello, and then push hello len, and then we can try to call a native write. I think that should be enough, but yeah, to call a native write, we'll have to include examples native hasm, right? And so that should actually write hello world. Yeah, let's give it a try. Let's give it a try. So build bin bosom. Do I have to provide the input? Okay, so here's the input. Where did I put this thing? It's located in here. So it's a test bosom. Where am I? Why don't I have this here? Why don't you autocomplete shit for me, please? Didn't I save it? I didn't save it. Okay, so that explains it. Bosom test bm. Okay, couldn't find file examples natives. Why? Examples natives. Okay, that makes sense. Cool. So we managed to compile that. I want to take a look at the debosom of this thing. I want to take a look at the debosom. Here is the test. And on the entry, we pushing 30 and 30. Nice. Thank you very much. So that was incorrect. So because we're pushing the address instead of the length of the function. So let me take a look. Push. So how was it called? Binding. So something about binding. Or maybe bind. Yeah, bind value. So the function that does that is a function bind value. And in here, what I'm trying to bind, in fact, is a word, but what I have to bind there is the length of that string. But what is the length of that string? That's a good question. What is the length of that string? I don't have an information about the length of that string, unfortunately. Yeah, I don't. I do have that information inside of the boson translate literal, so that means, yeah. Here it is, actually. Seriously, here it is. Oh shit, okay, so I can probably do some hack in there. So, yeah. Because it's a value, so that means the thing that we want to associate there is what is the location? Word name len word. Okay, cool. It's going to be value count -2. Yes. Oh shit. It's so okay. So it's kind of an interesting hack, but it is what it is. All right. So if I try to compile that, it's not gonna compile. Holy shit! I don't have enough time for that. Incompatible types. So it wants word U64, and yeah. Okay. So that will compile. Okay, perfect. It compiles. Now I want to build that and deboson that, and there we go. So we have 12. Right. So there in the original source code we had hello and hello len. So hello turned into 30, which is offset from the beginning of the static memory where the string was pushed. And hello len is the size of that string. If you take a look at the size of the string, it is 12 characters exactly. So in disassembly we can see that. So that length was computed at compile time. You don't have to do that at runtime anymore. That's the point, right? So that's exactly the point. Oh, all right. So that's very, very interesting. Alrighty. So we have that feature then. It's kind of started to get a little bit difficult to add new features here, because there's, as you can see, there is a lot of technical depth in here, but that's okay because we're starting to see patterns that already extractable. So the fact that I was actually hitting like recursive refactoring modes is because yeah, I'm starting to notice the patterns that could be extracted away. Yes. And something like bind, it shouldn't really return anything, right? You should be able to just bind a value, and if you cannot bind it, you could just, you know, crash and whatnot, unless you actually want to do something if you cannot bind a value. But I cannot see a single use case where you want to do something except reporting an error when the bindings exist. So that means this entire shit has to be within the bindings. Oh, we have a raid from Donho. Thank you for the raid. Thank you. And raiders, welcome to our epic, you know, Linux programming stream. How about that? We're making our own assembly language for our virtual machine. The assembly language looks like this. Yes. That's how it looks like. Does it look cool? I think it looks pretty cool. So, and we even developed our own editor mode for that. Alrighty. So, what I was doing, I wanted to recompile everything. And I also need to rename this entire thing because I was just doing compiler assisted refactoring, so I can rename this function back to that, and just check that still everything compiles. All right, everything compiles and all the tests are passed. So 77, make string literals introduce second binding for their size. All right, and we're gonna commit that. Alrighty, so let's push that right into the repo. Next thing. I have a bunch of to-dos that I want to actually tackle before going any further. One of them is moving this reporting stuff inside of the bosom bind value. I think it should be possible, right? So we already provide the location, and we do know about existing location. So my idea is going to be the following. I'm going to go and just copy paste this stuff into the implementation of bosom bind value. Okay, so if you're trying to resolve a binding and you manage to resolve it for some reason, right? You manage to resolve it while trying to bind something, we're gonna report straight up an error. So we're reporting the location, so we do know the location, that makes sense. We do know the name, so that also makes sense. And also we have existing location, so existing binding, so we can just reuse the existing binding location. Okay. Location. Cool. Will that work? Will that compile? By the way, did I commit the previous things? I don't think so. Yeah, I committed everything. Cool. That's pretty cool. So now, I think one of the things I can do, I can replace this boolean with void, because we don't have to basically signal any information to the caller of this function, right? So we can just not signal that and just do it like that, right? So, and that may require also changing the signature, so this one is going to be void. And let's just go through all of the usages of this function. We will go through them automatically because all of these places will fail the compilation. Cool. So now I can do the following thing. I can remove that shit, right? And also remove this condition, right? You want to make a binding? Just fucking make a binding. If it already exists, this function will report it for you, because that's exactly what we do anywhere, like everywhere where we use this function, right? What's the point of doing that? Like repeating that code over and over again. There's no reason to repeat that. Just fucking do that. There we go. And that will enable us with removing a lot of code. And by the way, because of that, we don't need existing anymore. So we'll be able to remove that argument from that function as well. We only have simplification. You see, spaghetti has evolved to the point where it's trimmable, right? So you shouldn't be afraid of spaghetti. Just let the spaghetti grow until you start seeing the patterns and just collapse those patterns. Just collapse those patterns. So that's how it goes. It's pretty straightforward. Don't be afraid of a spaghetti. Don't be afraid of a spaghetti. Alright, there we go. So, anything else? Let me remove that stuff. Right, and there we go. So, how much? Okay, so we're compiling everything. Everything compiles. The examples work, and we also run tests. So I made a lot of modifications, and that didn't break any of the tests. Perfect. Cool. Furthermore, next step is removing one of the arguments, because you don't need that argument anymore, right? You don't need to signal information about existing binding outside of that function, right? Because the only reason why it was needed is to report errors, but this function reports errors for you. So you don't need any of this shit. So now I can just take existing location and just put it like that. I just put it inside of it here. This is not a thing anymore. And I'm just passing it by a pointer. And yeah, might as well actually do it like that. Maybe I want to rename it to existing because it's shorter. There we go. So yes. So that simplified the function. Alright, so let's go through all of the places where we do know that. So you see, we don't have to pass this thing anymore, and since we don't have to pass it anymore, we don't have to define this function anymore. It's just not needed. Alright, and this is exactly the to-do that we're doing here, and we don't have to do that thing anymore. Yeah. So I still want to have it as a separate step in here, so everything is okay here. Alright, so existing is not needed. This thing is not needed. Cool. This is not needed and this is not needed. Alright, I think we've done it and everything compiles, so everything works, the tests are passed, and this is how much code we managed to remove. Yes. This is how much code we managed to remove. And we can try to test that. For example, in here, right, if you try to redefine... I have an idea, like hello 69, right? So if you try to redefine it, what's gonna happen? Oh yeah, I'm in a place where things are not compilable. One more time, const n69. Okay, n is already defined. The first binding was defined here. Perfect. Cool. So if I try to do it now, everything's okay. So what I want to check, whether in this place, if I try to define hello len, what will happen? It should tell me, I think, it should tell me that hello len is defined here. I think it's an adequate error message. Should be, at least. Yes, it's already bound. It was bound here, which is in fact is an adequate error message, I think, because yeah, so basically that place defined two bindings for you. Hello C everywhere. I think it's kind of a quirky a little bit, but it's an adequate message. Yes. It's pretty interesting. Sure. Let's remove this entire thing and yes. Yesu. Okay. Hello, Belgian. Welcome to the stream. Welcome. Okay. Also, I want to go through all of the places where we use the strings and where we compute the sizes of the strings all the time, and just, you know, use the length functionality of the string instead. I think it's going to be actually very pleasant to do. Right, so let me see. But first I want to do this thing. 77. Make bosom bind value report the error about rebinding, right? And there we go. So that helped us to get rid of the lot of duplicate code, which is super nice. Super nice. What else? I also had another weird to do. So, which is this one is complicated. I'm just thinking, what would be the best way to like have a concatenation function in this particular case? What would be the best way to do that? It would be nice to have like you know, a single concatenation function, if you know what I mean, like a string view arena sv concat, you accept the arena and a variadic functions, right? So essentially you would be able to push as many variadic strings there as you want, until you hit the one that is empty, right? So, or the null string, and it will show an indication that you're done doing this thing. Yeah, and just use it for everything. Even if you need to concatenate C strings, right? Even if you need to concatenate C strings, just use that thing, I guess. I mean, actually, you can do something like this. You can have a second one, which is a sister concat. Just have two of them, and this one also returns you const char. So no matter what you want, like just, yeah. I guess, and just remove everything else here, right? Just have two of them, SV concat and the sister concat. And this one is going to be variadic, it's going to do all of that stuff for you, and it's going to allocate all of the memory inside of the arena. Yeah, I guess. But I'm not going to remove these things for now, right, because they are needed for the refactoring reasons. Okay, let's go ahead and implement these functions. What do you guys think? Is it going to be useful functions? Maybe they're going to be useful. Where is it? SV concat. SV concat. SV concat 2. Right, SV concat 2. So this one is going to be a return. This one is going to be a return. So the problem with this kind of function is that you never know when is the end. So that's basically what it is, right? So you either have to provide the null terminator of some sort, right? Null terminator, or provide the count. Providing the count is the worst thing ever because you have to update it. Null is a little bit better, but you can still forget the null. The best option so far I found is to expect a null at the end of the variadic arguments and write a macro around this entire shit that you know that helps you with all of this stuff. So basically a helper macro where you're gonna put it like that, then va args, right, and then put a null here, you see? So basically, yeah, you need a combination of both macro and the variadic function. Yes, I missed a star. That's not the point. So, and I'm not sure which one we're gonna use here. Yeah, I guess we're gonna have a macro. We're gonna have a macro that also wraps and automatically puts a null there. I think that's gonna be the best option so far. Hopefully. I want to make a small break. I need to pee. So. It's gonna be 3 minutes. It's gonna be more. I think it's gonna be 3 minutes. That's right. Alright. Let's make a small break and you guys have fun. All right, I'm back. So yeah, let's start with this vconcat. Essentially, we're gonna do the following thing. Is everything okay? Okay. VA list. So we need the variadic argument stuff. It's gonna be args. First we need to start the arguments. I think this is how we do that. I think you put parameter as the second argument here, and then we're gonna have VA end for the args. All right, so here now I'm gonna have an argument here. Maybe I'm gonna just call it SV then. So it's gonna be VA arg SV string view. There we go. And while SV data not equal null, we're gonna be iterating over all these things and just collecting the information about them. Just collecting the information about them. But do I really want to have like a concat, or do I want to have actually join? Because join could be more useful for separation and stuff like that. But we can implement that later. Let's just implement concat first. And essentially what we're going to do, we're going to just accumulate the sizes. By the way, my kettle is over, is done, so I'm going to quickly pour a cup of water. All right, so there we go. So we're gonna actually keep track of the final length of the concatenation, right? So essentially we're gonna do that like this, plus SV count. So we're iterating through all of the variadic arguments and we accumulate the length. After that, we know how much memory we need to allocate, right? So we're gonna do alloc arena, and we're allocating this amount of memory, essentially. We're gonna put it into some sort of like a buffer, right? So this is basically what we're allocating here. Afterwards, we need to do the second iteration, right? We need to do the second iteration to actually append everything into the buffer that we just allocated. So I might as well copy paste this entire code. Copy paste it like that. Right. But instead of accumulating the length, I'm gonna actually append the strings into the buffer. So the way we're gonna do that, I'm gonna reset the length back to 0 because I'm gonna use it as a tracker of how much we fill the buffer. And I'm gonna do the following thing: copy buffer plus len, and I'm copying the SV data, and I'm copying SV count amount of bytes. After that, I'm gonna do plus SV count. Lost algorithm. Hello. Arena concat 2 strings enter, 1 strings leaves. No, I don't understand what you mean, but this one is a variadic function. It actually has, it accepts more strings. All right. So yeah, so we do like double iteration because that's what you have to do with variadic arguments in C. There is no other way, absolutely, like completely. And so we're gonna put it like that. It's gonna be string view. So the count is gonna be len, and the data is gonna be the buffer that we just allocated. There we go. It's a Mad Max movie. Oh, I never watched it. I'm sorry. So yeah, thank you for explaining it. Yeah, I never watched Mad Max. I know what it's about. I kind of know some of the Mad Max memes, but I never actually like sat down and watched it. But I heard a lot of good things about this movie, so maybe I should finally watch it. I don't know. It's kind of difficult for me to watch movies because it's like find it difficult to focus on watching the movie. So yeah. All right. So yeah, this is how we can concatenate things. Yeah, I think we should give it a try. So Arena sister concat is going to be similar, but it's going to work with sisters instead of SVU. All right. So let's try to build this entire stuff. It doesn't even compile properly. God damn. To type qualifiers ignored. Oh yeah, so it has to be this. VA list, we have to import stdarg then. What's up, old man? Hello. stdarg.h. Alright, so cool. First, oh yeah, it has to be args. Yeah, it has to be args. And it has to be args. So this is the redefinition. We don't need to redefine anything. And maybe I want to kind of rename this thing to arg. It will require too much renaming, so I'm gonna keep it like that then. So oh yeah, it's a similar situation. This has to be args. This has to be args. Has to be args. Semicolon. Okay, finally. So this entire thing seems to be compiling. And what do we have here? We have unused arena, so let's actually just ignore it for now. I might as well put an assert in here. Band? Who's band? I don't understand, sorry. Is not implemented. There we go. In the link. Let me take a look at what's that. Oh, I see. Cool. Yeah, it's against Discord TOS to be 13 years old. Speaking of ageism, by the way. I'm programming a virtual machine in C. Hello, IIUMII. I don't know how to read your nickname, but hello. You can check out the !today command to get the link to the source code of the program that we're developing. And we're also drinking tea, by the way. Cheers. Earl Grey, yes. What's up, the Thinner? Welcome to the stream. What's up, what's up? What's up, what's up, what's... Oh, I should stop. We're drinking Earl Grey today. Alright. So, Big Connect. Seems to be compiling, but I need to test this entire stuff. How can I test that? Maybe I'm gonna go to some of the examples, maybe to some of the source code things. Hello, Dr. Poopy, welcome to the stream. How are you doing? So I might as well actually do something like main.c and define VM implementation. It's going to be include src vm.h. Didn't want to say that. Full-fledged VM or container. What do you mean by full-fledged VM and what do you mean by a container? Apparently it's pronounced like Yumi. Oh, okay, thank you so much. Sure. Yumi. So a VM in C, do you know other languages? If yes, which one? Else, would you like to? No. Basically, I do know other languages and I wish I didn't. Let's put it this way. So Psst. want to learn more languages. Which editor is this? This is a text one. This is a text editor. What you talking about, Rust, Mr. Streamer? Nah, I'm talking about all of the languages I learned over 15 years. Yes. I wish I didn't learn them. Okay. So, yeah, we need to define arena. Let's actually put the arena somewhere here. Arena. Except maybe PHP. PHP was good, I think. PHP was pretty cool. 15 years of useless knowledge. Exactly. That's what it feels like. Holy shit. Arena. Your hardware got delivered. Nice. That sounds cool. What hardware though? If it's not a secret, of course. So we provide the arena, and we can provide. Thank you. I'm actually, coincidentally, I'm hungry right now. So yeah, thank you. Oh, I really appreciate it. Hey, good day. What is your preferred C test runner? Linux kernel actually works kind of great for running C tests, I think, especially if you compile down to ELF object file that is executable. Then you can basically give it to the Linux kernel and it will execute it and just run it for you. It's actually kind of great. And on top of that, if the executable exits with the non-zero exit code, it will get delivered to your shell, and then you can inspect whether the test failed or not. It's actually a pretty great feature. So imagine like test runner built into the kernel, into the Linux kernel. I think it's amazing. Fourth, what's up? Hello, welcome to the stream. How are you doing? Right. Hello, John Pung Thong. Welcome. I'm fine. I'm fine. How are you? Did you start improving your programming skills? Do you program daily now? Hopefully you are. Hopefully you do. You're great. Nice. Remember, to get better at programming, you have to program regularly, right? You have to do that every day, right? Yeah. Work on some projects, you know, some pet projects and stuff like that. Yeah. Must be aware. It doesn't have to be, right? But if you want to get better at something, you just have to do that more, right? You don't owe anything to anybody except maybe yourself, right? Maybe you owe that to yourself. But if you want to get good at something, just do that more, and yeah. So we basically make a test folder with a bunch of files that have a main and compile to run them. Got it. I just started using C, finding hard to follow modern parents on it. Is there any modern parents in C? I don't know. So C and modern parents sounds like oxymoron, to be fair. Like, it's an old language. It uses old ways of programming. It's one of the like active languages that somehow retained the old school style of software development. The one this is similar to like BASIC or something, or assembly, right? Somehow it just retained like the old school way of things. I don't know why. So I don't think there's anything modern about C. It's like quite the opposite. Alrighty. So let's actually allocate a bunch of things. So SV from sister, right, it's gonna be hello. So we're trying to concatenate a bunch of things in here. So SV from sister world, and then you have to actually terminate all of that with a null string view. So let's actually introduce a macro called svnull, and it's going to be literally string view 0. So after that, once you've got some result, or maybe just a sv, let's just call it sv, I think it's going to be enough, you can try to print it. And the way you're going to print that is result svfmt svarg sv. There we go. By the way, I actually fell in love with Ivy and Sweeper. Okay, I never tried them. To be fair, I kind of stopped trying to like improve and tweak my Emacs config. I had a phase in my life where I was like extensively customizing my Emacs, but I kind of like grew out of that phase at this point, so I just want to have a basic editor and nothing else. Grammatical on parsers, not literal Google search point. Welcome to the Todding channel. Why is it so hard for JS developers to understand pointers? Because JavaScript doesn't have pointers? And, or at least they're not necessary to write JavaScript programs, so they have zero practice for it. Though they still need to understand pointers as they interact more and more with WebAssembly, right? Because the way you interact with WebAssembly, you create a region of memory, right? And essentially, all the information from the WebAssembly context is returned through the memory, and you need to know the offsets of the memory, right? So we basically communicate with the WebAssembly context using offsets in the memory. And what is an offset in the memory? Well, it is a pointer. On top of that, pointers in C, on top of having like semantical meaning of being offset in the memory from the 0, they also have a lot of syntactical garbage. Right. I think the main reason why people don't really understand pointers while learning C is that because C is a syntactical disaster when it comes to these kind of like types. Right, and that's why we have such thing as cdecal, right? Right, so the main difficulty is not understanding the semantic of pointers. The main difficulty is understanding the syntax of the pointers, and it's fucking disaster, seriously. And this is the reason why we have websites like this, right? So, yeah, you essentially have a C gibberish that looks like this, and in fact, what you're doing, you're declaring a bar as a const pointer to array 5 of pointer to function int, returning const pointer to char, and this is how you do that, you see? So C is a syntactical disaster, and I think it's a main contributor to people not understanding how pointers works, because semantically pointers are just fucking number. It's an offset from a particular position in the memory. It's like index in the array. It's like an index in the array. So yeah, I would blame C syntax for you know, making it difficult to understand this kind of shit. All right. So what we're trying to do here, we're trying to concatenate this entire stuff, and yeah, let's try to compile this thing. Main, let's see. Does it compile? It does compile. Now let's try to run it. And it worked. We concatenated hello and world, and that's exactly what we wanted. I can actually add more things in here, and it will concatenate them as well in one go. There we go. Maybe I'll check it out in the future. Oh, okay, it's not for me. I feel like you listened to Lex Fridman referring to the statement about how to learn programming. Probably. I don't know. I watched some of the Lex Fridman podcasts, but I feel like this kind of content is not for me. I just don't find it interesting for some reason, because majority of the podcasts is just him asking opinions of famous people in computer science and math and whatnot. And I don't really care about opinions, seriously. Like, it's it's something that I don't really find interesting. Yeah. So, and every time, there's nothing wrong. I understand why this kind of content is popular, right? It's just, it's not for me. It's just literally not for me, and yeah, sorry. You want some opinions? Yeah. It's like maybe the reason why I don't care about opinions that much is because I hear them every day. Because of the specifics of my job, I'm basically forced to listen to opinions on different kinds of topics every day, and I'm just kind of, yeah, cool. So anyway, I don't know, I'm not complaining, just saying. Just explaining. This is not an excuse, it's just an explanation why I don't find this kind of stuff not interesting. Yeah. Okay. So, what's interesting, will it crash the program if I don't provide the null? Okay, so this is A, and it didn't, but that doesn't mean shit, actually. That doesn't mean shit. So if I try to do something like this, it may crash it. Nah, it doesn't crash it, but it's very dangerous because we use null as an indicator of the end of this entire thing. And let me tell you, it's super easy to forget to add that null there. And this is why I usually, when I create this kind of periodic functions, I'm creating a macro, svconcat, where I accept an arena, and I automatically just basically add that null there. So it's going to be va_args, and I just do sv null in there. So that way, I don't even have to provide null ever, and it will never forget to do that. So yeah. Zosin, just define a return type. It's not a bad idea, I suppose. Yeah, so you can wrap C syntactical garbage into macros and make it easier. I guess you can do that. All right, so that's pretty pogue. Let me try to compile that and see if it compiles. And of course, you can always add more. Right, you can always add more. svconcat, something went wrong. Yeah, so this is basically what went wrong. And by the way, all of that is allocated within the memory allocator. We can do something like arena summary to take a look at the structure of the arena after all of these allocations. Right, and oh yeah, arena is actually turned out to be very small, so I can probably do a capacity 640, 100, 1000. I mean. Yeah, this one is actually very easy to forget to do, but yeah. And also you can do arena free. Maybe I should have like a default capacity so you never forget to. Yeah, should have a default capacity. Rewriting C with macros. Nah, it's not that convenient in my opinion. Alright, so I want to move these macros back to the original library. So string view. Where do we define string view? Alright, and this is where we're gonna have a null. And here, well, not really here, but arena sv concat. Yes. So this is where we're gonna have this macro. I can't write anything without misspelling something. Yeah, same. And this is one of the reasons why I don't particularly like dynamic languages, because they make it difficult for me to develop software. Alright, so we implemented this thing for SV. We need to implement a similar thing for sister concat. Right, so let's quickly do that. There we go. So it's going to be kind of similar, but except of working with string views, we have to work with C strings. Do you prefer PureC over using some C++ features like functions overloading? To be fair, the answer is more complicated than yes or no. It depends. I like the simplicity of C, but at the same time, in the modern age and era of complexity of the software, the simplicity of C is just not enough to cut it, unfortunately. Yeah. The right tool for the right job. Ugh. God damn it, it's such a cliche phrase. My god, please stop. All right. So, so we're gonna do a similar thing. We're gonna keep track of the of the len. VA list args, and it's gonna be VA start args arena. The simplicity C is not enough. Somebody tell Linux quick. And so what? I don't think he would care about the opinion of some random freak on the internet like me. So, function overloading, and I'm not even talking about function overloading. I'm talking about more about a more static typing and more compile time features. That's what I'm talking about. Yes. All right. So we do VA start, and then we're gonna have const char sister, and it's gonna be arg args const char. There we go. And while sister is not equal to null, we're gonna be repeating this into stuff like that. So Rust compiler for C, but without the Rust spirit? What the hell are you asking? You're okay. What does it even mean? This phrase doesn't mean. What is a Rust compiler for C? If you have a Rust compiler, it compiles Rust, not C. And what is a Rust spirit? It doesn't make any sense. It doesn't tell me anything. I'm sorry. All right. So here's what we have here. Str len sister. So again, we're doing the same thing. We're accumulating the lengths of the strings, right? The length of the strings, and then that will be enough for us to allocate a memory for the sister. So how are we gonna do that? So it's gonna be a buffer, right? And we're gonna do arena alloc. And what we're gonna allocate here? We're gonna allocate length, but +1 this time because we need to accommodate the null pointer. Okay. So after that, we're gonna set it to 0, and we need to repeat this entire thing one more time. So we start iterating through all of that, and instead of updating this entire stuff, I'm gonna do it like that. It's gonna be size tn strlen. Hello, Uncut, welcome to the stream. Hello, hello, welcome. Really glad to see you. All right. Okay, so yeah, I'm gonna do mem copy, and I'm copying to the buffer plus len, and what I'm copying here, I'm copying sister, and I'm copying n, which is the size of the sister. Makes sense, right? And after that, I need to add the size of the sister. There we go. So we constantly filling everything up. All right, so now buffer len equal 0, and then we can just return this entire stuff. There we go. So now we have a similar function that does the same thing but for sisters. Perfect. Alrighty, so this yeah, there's a redefinition situation, and let's avoid that. Okay, cool. So I'm gonna go back to the main, and now instead of trying to do something like this, yeah, we want to do arena sister concat, arena sister concat, and we can remove this entire stuff. Probably something like this, right? And it's gonna be null. Let's put it like this, right? And the result has to be also sister. So, and we're gonna put it like that. This is the sister, and oh my god, Emacs. Oh, cool. Alright, works quite well, and I can also try to add something more just to check how it works. Yes, it does concatenate everything correctly, but again, it's quite easy to forget to put that null there. So we'll have to wrap all of that in a similar macro. So it's going to be sister concat. It accepts the arena dot, and then it's going to be arena sister concat arena varg, and instead of sv null, we're going to just have a null. There we go. So yeah, so now you will never forget to put that null there, and now we can do something like sister concat. There we go. So now you can easily concatenate as many strings as you want, and everyone should be happy, hopefully. Cool. So now we have two like main concatenation functions. We can get rid of all of that madness for sure. We shouldn't remove this one, but we do need to remove these functions because they don't make any sense anymore. Before we can remove everything, I think I want to commit whatever we have. Yeah. So let's do a committee. So that's pretty pogue. 77. Implement arena sv concat and arena sister concat. There we go. Boom. So basically, SV and sister are two different styles of strings in C, right? Sister is a null terminated string. This is what I call a null terminated string. It's a classical old school C way of handling strings. And SV is a string view. Essentially, it's a size plus the beginning of the strings, which doesn't require any null termination. And we support both of them. We have conversions between these kind of strings. Our primary parsing is happening within string views, but when we need to interact with the C libraries, we have to convert the string views to the null terminated strings. So yeah, it's kind of like, yeah, there's nothing we can do about that. That's why we need to support both of them. All right, so cool. So now I can remove some of the stuff that is not needed anymore. I can remove these concatenation functions that don't make any sense. Yeah. And the reason why converting SV to sister requires an arena is because to add additional null terminator, we'll have to allocate more memory and copy the whole string there and put a 0 there. So there's no a way around it. You can convert sister to SV without allocation, but you cannot do the reversed conversion without allocation. Iterating over strings twice to concat PepperJam. Yes, welcome to C variadic functions. Actually no, it's not really about variadics, because what you get, you have a list of strings, right? So first you need to know the final size of the string. So that means you need to concatenate all of the sizes. This is first iteration. Then once you know the size, you can make one single allocation, and you need to do another iteration to actually push everything into that buffer. I don't think it has anything to do with the variadics in C. It's just like a fundamental problem of this approach. Yeah. I don't think it has anything to do with sister, because we have to do the same thing even with SV. Even with SV, you still need to iterate through all the SVs and concatenate their sizes. It's just, nah. All right. So what do we got? Everything seems to be okay. Good. Oh, it still compiles. God damn it. And this is because we have dead functions and whatnot. Yeah. All right. Let's try to rebuild everything here. Okay, so here is that. This is unused. This is also unused. This is also unused. Not needed anymore. Alright, so oh yeah, nice. So we have sv concat. Now I can just use sv concat, provide the arena name, and there we go. And I can actually do it like this. Yeah, I can just do it like this. Nice. Cool. Sister concat too. So this is something in bosom. Oh shit, that's cool. So I can now do it like that. Oh shit, that's cool. Do we have anything else? Okay, so there's another problem in another place. Okay, this is sv concat. So that means I can do something like this. And this has to be sv from sister. Because executable, I would assume executable is... Oh, it's a sister actually. Alright, so I can try to do it this way. We're gonna concatenate these things as sisters, but then we're gonna convert them to SV. Right, and converting a sister to SV does not require any memory allocation, it's actually free. So we can do it like that then. Okay, and it seems to be working. And let's run the tests and see if we didn't break any tests. You're doing strlen in sister version, it's a lot worse. Yeah, probably. But the computers are fast. I mean, iterating over memory is fucking cheap as hell. Iterating over, like, you know, other memories is worse. But maybe not. Depends. Depends on the caches and stuff like that. It's complicated. Alrighty, so did I fix what I wanted to fix? Let me take a look at the to-do. Yeah, make arena concat more universal, whatever that's supposed to mean. This is what it's supposed to mean. Now we have a universal concat functions. We have a universal concat functions. But Zosian, why are you programming in a language that has fundamental problems then? It's a good question. I think this is because I have issues. Alright. Alright. So this is how much code we removed. Excuse me. Oh shit. Oh yeah. Wait, what? Oh, I didn't. Yeah. 77. Remove deprecated string concatenation functions, and I'm gonna push that right into the repo. Do we have anything else? Thank you, sir. And what I was doing actually, 77 was about what? I went on such a huge yak shave. I forgot what it was. Arena make bosom. So the issue was about there's no way to get the size. Oh yeah, okay. So that required like a little bit of a refactoring to get right. Okay, so this is basically what we did here. Oh yeah, and I think another thing I wanted to do, I also wanted to go through all of the examples. And use that functionality of getting the size of the string and whatnot. And of course this entire thing fails on Windows. Classic fails on Windows. I'm super happy. Alright, and why does it fail on Linux? Because the following warning is treated unreachable code. Oh, at least I know what it is. Hello Gil Christian, welcome to the stream. 1454. Are you sure this is unreachable code? Okay. Sure. Fix unreachable code warning in MSVC. Alright, so I'm gonna push that right into the ribbon. So hopefully it will work now. Haha. Haha. Okay, that's a lot of changes, but we also did a little bit of refactoring, so hopefully the spaghetti is actually shrinking. The spaghetti is actually shrinking, and I was streaming for almost 4 hours, and unfortunately I'm a little bit tired, boys and girls, so I think I'm gonna call it a day for today. Yeah, I think today's day was pretty productive. We did a lot of stuff, we merged pull requests, and also implemented a couple of things. But unfortunately, it is time for me to go, boys and girls. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you tomorrow. Tomorrow, according to the schedule, we're gonna continue doing this thing. So yeah, check out our schedule for more information on different projects we're working on. Check out our VODs channel for the recordings of the stream, This stream is going to be there, but tomorrow. And also check out our Discord server for offline discussion with the community. And yeah, that's it for today, boys and girls. That's it for today. By the way, I think I can do the final merge before I go. So yeah, there we go. The stream is complete. Everything has been merged. The issue is officially fixed. Thank you, everyone. Love you all. Mwah.